All right, I am going to walk you guys through the lesson that we would have gone through if our class wasn't canceled for Thursday. So I'll keep it pretty short. This lesson is on properties of matter. And the first thing I want to show you is that your assignment that you worked on, 6.2, I did post a key for it. And I tried to find some that I thought might be a little bit confusing and give you a bit of an explanation for those too. So if you're like, I don't know, I put homogeneous mixture for seawater and I wasn't sure why it was heterogeneous, I tried to think about the ones that you might find confusing. And explain this is why that's a heterogeneous mixture because of all the sand and the organic matter that's suspended, for example. Okay, so when it comes to properties of matter, so we talked last time about what matter is and how we can classify it, and now we're talking about how we can describe matter. So any properties that we're thinking of are either going to be chemical properties or physical properties. A chemical property describes how a substance will interact with other substances. And the only way that we can observe a chemical property is by actually changing what the substance is. So if it's an element or compound, we're changing it into a different element or compound. If it's a mixture, we're changing the components of that mixture. Whereas our physical properties are things that can be measured without changing the substance. So physical properties can be either extensive or intensive. So if we had kind of a diagram, we would have chemical and physical, and then our physical would be broken up into extensive or intensive. So these are categories of physical properties. So extensive physical properties depend on how much of a substance is present. And intensive properties do not. They're things like color. That doesn't depend how much I've got. Or temperature. It doesn't matter how much I have. Whereas things like mass and length, they depend on how much of the substance I have. So those are going to be extensive. I tend to remember these thinking like, this is a little bit silly, but this is how I remember it. So I think of intensive as it's like an internal property. It's something that's true no matter what. It's true regardless of how much we have. So it's internal. It's more kind of innate to the substance. That's kind of how I remember these, where I think of extensive almost like external. It depends on the external circumstance of how much we have present. So that's just a little way that I try to remember these. All right, so I have a couple of examples here. Obviously, you guys can't fill in on this pear deck right now, so we'll just go through these and I'll classify them each. So mass is a physical property because I can observe it without changing the chemical substance. And it does depend on how much of the substance I have present. So it's a physical property and it's an extensive physical property because it depends how much I have. Solubility in water. That describes to me how whatever this chemical is going to interact with water. That tells me about how it interacts with other things. It's not something that I can observe without making a big change to my substance. So this is a chemical property. Density is a really tricky one that people sometimes struggle with. Most of us know this is a physical property because it's something I can measure without changing the substance. But when it comes to whether this is extensive or intensive, it's a little bit tricky. So density, we might think would change based on how much of a substance we have present, but it's actually going to be the same no matter how much, because that ratio of mass over volume that we use to calculate density is going to be the same no matter how big my substance is. So for example, the density of water is about 1.0, and that density is the same whether I have a little bit of water or a lot of water. So this is actually an intensive property. It's something that's true to the substance regardless of how much I have. Acidity is something that describes how my chemical will interact with other chemicals. How does it interact with acids and bases? So this is a chemical property. I can only observe that by, for example, I could put it in with a base and see if there's a reaction. Boiling point is a physical property. And it's a physical property that doesn't depend on how much of the substance I have present. So this is an intensive physical property. Reactivity with oxygen. So any form of reactivity. So this is the question of, is this substance going to react in the presence of oxygen? That's a chemical property because it tells me how is this combining with something else. Color is a physical property. It's going to be the same color regardless of how much I have, so this is intensive. Volume is something that I can observe easily without making a change to my substance, so it's physical. But it does depend on how much I have present. If I have a small sample, I have a smaller volume. If I have a big sample, I have a bigger volume. So this is extensive because it depends on that external circumstance of how much I have present. Freezing point, very similar to boiling point here. This is physical. I'm not making a chemical change. I'm making a phase change, but that doesn't change my substance. If I have water turning to ice, then I have a physical change of water changing to ice, but it's still water all the way through. So these phase changes are example of physical changes. And the freezing point, the temperature at which my substance will freeze is going to be an intensive property. It doesn't matter how much I have, it's going to freeze at this temperature, whether a little bit of it is freezing at that temperature or a lot of it. And last, flammability. The only way for me to observe that is to see if something's going to catch on fire. So I am going to call that a chemical change because it's describing how that might change in the presence of another substance. So hopefully seeing some examples helps you when you do your practice. All right, and then the last thing I'm going to talk you guys through is changes in states of matter. Oops, I think I'm on the wrong slide. Oh, no, I was just recapping. So then in addition to when we're thinking about those properties, if we have a change to those properties, we're going to call them either physical changes or chemical changes. So chemical changes change the actual substance, and they make a change to one of those chemical properties that we just looked at, whereas physical changes only change the physical properties, but they don't change the identity of the substance. So for example, cutting up a piece of paper, it's still paper, it's just cut up. That's a physical change. Burning a piece of paper, well, now I've made a reaction of that paper is turned into carbon dioxide and and water vapor. And so that would be a chemical change. And then the last piece I want to talk to you guys about is states of matter. So like I said, changes in states of matter are physical changes, but let's look at them just a little bit more. So state of matter is a physical intensive property. If it's a solid, a liquid, or a gas, it doesn't matter how much of it there is. It just depends on what that substance is and what the temperature is in the room. Changing a state of matter is a physical change. I also have a brief note about plasma here. Plasma is a state of matter, but it's achieved through more specific conditions than we're thinking about in terms of like melting, boiling, freezing. So we aren't going to get a ton into plasma. I want you to know what it is, but I'm not going to ask you much about it. So I want you to just have kind of a general sense of what is plasma, and that's in your reading. All right, these are just some vocabulary terms that you might see throughout the year. Most of these you probably know. Evaporation is liquid to gas. Gas to liquid is condensation. That's what you see on your glass forming. Solid turning into a liquid is melting, and liquid turning into a solid is freezing. So those are ones you've probably heard before. The ones that might feel a little bit more new are the terms sublimation and deposition. So if a solid turns straight into a gas, that's called sublimation. You may have seen this if you open your freezer, you can see the gas actually coming off of your freezer a lot of the time. That's an example of sublimation. Another example you might be familiar with is dry ice, which is a solid that's just sublimating into the air. So we see that gas coming off of that solid block of dry ice. And then deposition is gas to a solid. I don't think in real life I've seen any that I can think of examples of deposition. Maybe when solid ice crystals form in really cold temperatures, it's the only thing I can think of. Like if you see those solid ice crystals forming on your window, they may not hit liquid in between going from gas to solid. But anyway, I just want you to be familiar with these terms, sublimation and deposition, because you will see them throughout the year. All right, and then these are the key points from your reading that I wanted to highlight. So a solid has a defined shape, and the way the particles move is that they vibrate amongst each other. A liquid takes on the shape of what it's in, and the particles move by kind of slipping and sliding against each other. And then a gas also takes the shape of what it's in, but those particles move around more freely. I really just tried to pull out what is the shape that this substance takes on, and how do the particles move from your reading. So those are the key points I pulled. And then I have just a picture on the right of the way those particles look in the micro scale when we're looking at a solid, liquid, or gas. Okay, and that is the last one that I have for you. So I just wanted to go through those pretty quickly. The assignment that I have you working on to practice physical and chemical changes is a Jamboard. So when you click on the assignment, it's going to take you to a make a copy page, and you'll make a copy of this document. It's got just kind of some of the key points that we talked about here to highlight for you, some notes. And then what I have you doing on this third slide is I've got these examples, and I want you for each one to be just categorizing it. So you're just taking these and you're sorting them as either physical or chemical changes. There aren't that many in there. And then I don't think there's anything on this last slide. Yep, and this is just a reminder to submit your assignment and upload it using your Google Drive. So when you go to upload this, you're going to click into Files, and it'll take you to your Google Drive, and that's how you upload the assignment. So that's your 6.5. And then I'm going to be posting the quiz later today. All right. Thank you, guys. Bye-bye.